I'm going to begin by talking about rack management. Rack systems are specially designed racks used to hold networking and computing equipment. Sometimes they are referred to as server racks. These rack systems follow one of several different designs. However, they all follow the same height specification. That specification is the standard unit, and it's designated by the capital letter U. Now, the standard unit involves the amount of vertical space that can be used to hold equipment. A standard unit is equal to 1.75 inches. So a 15U rack has 26¼ inches of vertical storage space. Most rack servers and enterprise-level networking equipment are designed to fit within rack systems. There are several different types of racks. Racks are normally either 2-post or 4-post racks. They may be freestanding or they may be floor-mounted. Server rail racks have slide mounts to make it easy to pull out servers to perform necessary maintenance. Now let's talk about device placement. Devices that generate the most amount of heat or are not heat sensitive should be placed towards the top of the rack. Devices that generate the least amount of heat or are heat sensitive should be placed toward the bottom of the rack. All equipment cold air intakes should face the same direction. All equipment exhaust outlets should therefore also face the same direction. When mounting equipment in racks, vertical space should be left between the equipment to promote adequate airflow. When multiple rows of racks are implemented, a hot aisle cold aisle approach should be used to promote proper airflow and cooling. Racks should be monitored for environmental factors to help ensure the health of the servers and other equipment. Monitors should be in place for temperature, humidity, vibration, water leaks, smoke, and intrusion. And that brings us to rack security. Most rack systems do not come with rack security in mind, but it can be easily added after rack installation. Rack doors can be added that have either keyed or electronic locks. If the equipment is not secured, it can be easily stolen. Now let's have a brief discussion on power management. So before I begin talking about power management, let me give you a little bit of trivia. We're all familiar with the power symbol that you see there to the right. That's actually a binary symbol. What that is a 0 with a 1 poking through it. I know, not very relevant to today's discussion, but it's an interesting bit of trivia. Now, power is often overlooked when designing a network. However, without power management, the network may never work properly. Most people assume that when they plug a piece of equipment into a wall socket, that piece of equipment is going to power up just fine. In most cases, they are correct. However, if the circuit cannot provide enough amps to the equipment, damage may occur. It is important to know the power requirements and loads for all of the equipment that will be in place. This helps to ensure that the proper electrical circuits are installed so that sufficient power is delivered where it is needed, when it is needed. Power converters convert electrical energy from one form to another, as in from AC to DC, or from one voltage level to another. On the other hand, power inverters are a type of power converter that specifically converts voltages from DC to AC. Then we have the uninterruptible power supply, the UPS. It uses power converters to receive electrical current from an AC electrical source, and it passes that current to a battery or set of batteries for storage. It then uses a power inverter to receive DC current from the batteries and pass it to another device as a conditioned and well-regulated AC flow. They're used to provide a steady stream of conditioned electrical power to components. They help to protect sensitive electrical components from power anomalies, either from power spikes, power outs, or from power sags. In some cases, you may want to consider installing power redundancies. Critical components should include redundant power supplies. That means that if one power supply fails, the other one takes over immediately without any loss of service. Now I'm going to begin by talking about cable distribution. And the first item under cable distribution is the main distribution frame, or MDF. This is the location where the demarc extension, main switch or router, and patch panel are placed. The MDF is where outside traffic enters a location and is then distributed to the internal network. It is possible to also have an intermediate distribution frame, or IDF. It's a locations solution for when a single MDF is not sufficient. They usually occur in multi-story buildings. The IDFs are connected to the MDF by vertical cross-connect cables, or VCC cables. It is common for an MDF to contain separate IDF panels for each floor of a building. A vertical cross-connect is the main patch panel for a location. It usually resides in the same location or very close to the demarc and main switch or router. I mentioned patch panels earlier, so let's talk about those. They're used to terminate network cable runs, usually within a building, as in from the wall jacks to a central location. The network runs are called horizontal cabling. Patch panels are used to organize and administer the physical aspects of the network cables. Network runs are punched down to the back of the patch panel, which normally contains either a 66 or a 110 block, with an associated port on the front of the patch panel. Patch cables are used to connect the patch panel ports to networking gear, quite often a switch. Workstations connect to the patch panel using horizontal cabling. This location is called the horizontal cross connect, or HCC, and is usually located in the IDF. Switches may or may not be present in this location. If a workstation needs to be relocated to a different switch or port, all that needs to be done is to make the change in the location of the patch panel. So you unplug the cable from one port and you plug it into a new port. With that covered, let's talk about cable management components. Labeling is an important part of cable management. It can cause stress when working with networks, but it doesn't have to. The key to proper labeling is to create a naming convention, which is a systematic and consistent method that makes sense for the situation. Proper labeling will ease the management of the physical aspects of the network, especially when dealing with cables. Labels should be placed on everything that deals with the network, beginning from the wall jacks all the way through to the patch panel, switches, and routers. The naming convention should be documented and kept with the network diagrams. Let me give you an example of a naming convention. Suppose Office 219 has network outlets on all four walls. The jacks could be labeled 219N, 219W, etc. And that would be for 219 North or 219 West, etc. The horizontal cabling from 219 feeds into a patch panel in an IDF located on the second floor that contains two 48-port switches that tie in all the horizontal cross connects. The cables coming in from Office 219 to the patch panel could be labeled 219W or 219S, etc., as it relates to their location in the office. The switches could be labeled SW2A and SW2B. Now suppose that the patch cables for Office 219 connect to switch 2B's ports 20 through 24. The patch cables could be labeled 219N-SW2B-21 or 219E-SW2B-22, etc. The key is to be consistent and to document everything. And finally, there are cable trays. Masses of cables can block airflow and act as an insulator that allows for excessive heat to build up. Cable trays are used to organize cabling and to keep it away from areas where cabling may cause heat to build up. Cable trays keep bundles of cables neat and fairly well organized. That